Hello everyone. So today let us try to discuss how to calculate the degree of static indeterminacy of a truss. So here we have considered two truss members. A truss is a frame only, but it takes loads at the joints, and it is basically having a tendency of like being a triangulated structure. Okay. Now for this truss, the formula is this one for 2D truss, and this is for 3D truss. Now for 2D, m plus r minus 2j. What is m? M is the number of members, r is the number of reactions, and j is the number of joints. Now if I try to calculate for number 1, how much will be m? M will be how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So M is 22. Number of reactions, hinge is giving 2, ruler is giving 1. So reaction is 3. Joints, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Joins 12. So m plus r minus 2j will be how much? 22 plus 3 minus 22 into 12 is equal to how much? 25 minus 24 equal to 1. So this is how we calculate the static indeterminacy. Now you see in this region we have considered two members, isn't it? But we can consider this as a joint and consider four members also. So let us see how the result becomes if we consider this joint and these members as four members instead of two. So in this case, uh, let us do the calculation. Let us start with, suppose, joints. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then M, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I'll just correct it once again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. M will be 24 and R will be same, 3. 2 here and 1 here. So the final result will be how much? M plus R minus 2j. It will be 24 plus 3 minus 2 into 13. It is becoming 1. So you see, it's better if you use this method. I would prefer this. This will be much more proper. So this is how we calculate the degree of static indeterminacy for a truss. And now let us try to get some basic like let us try to have some basic discussion about kinematic indeterminacy. We'll be doing kinematic indeterminacy now. So kinematic indeterminacy is the basic equation for finding out the kinematic indeterminacy. I'll just write it down. You also please take note of that equation. So kinematic indeterminacy is also called as degree of freedom. Now, the main equation will be kinematic indeterminacy equal to total degree of freedom of all joints minus number of external reactions minus number of inextensible members plus additional degree of freedom due to hinge, which is the internal hinge. How to find out the additional degree of freedom due to internal hinge? If the hinge is like this, then it will be taken as 4. Any member, if you find this one, we have to add plus 4. And if it is in the joints, then it will be for 2D it will be m minus 1, and for 3 this is for 2D, and for 3D it will be 3 into m minus 1. This is for 3D. So this we have to add it here. Additional degree of freedom due to hinge if it is there in the structure. So like if we try to take one example, degree of kinematic indeterminacy is also written as dk. So it will be, now you see, total degree of freedom of all joints. How many joints are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 joints each have 3 degree of freedom. Two linear and one rotational, two translational and one rotational. So total 3 degree of freedom. Then minus number of external reactions. How many external reactions are there? 1, 2, 3, 4, 5, 6, 7. So there will be 7 minus number of inextensible members. There is nothing mentioned about inextensible members. If the in the book there in the question there is anything mentioned about inextensible members, if there are 3 inextensible members, inextensible means what? Which does not, it does not get elongated. It cannot be extend, it cannot get deformed. that is called as inextensible member. If it is not mentioned, you can just write 0. Okay, plus additional degree of freedom due to, is there any internal hinge here? There is no internal hinge, so it doesn't matter. So ultimately it becomes how much? 20. So this is the way of calculating this kinematic indeterminacy. If I take another problem, what will be kinematic indeterminacy? How many joints are there? 1, 2, 3, 4. So 4 joints into each joint has 3 degree of freedom minus number of external reactions. How many? 1, 2, 3, 4, 5, 6. So 6 external reactions minus, nothing is mentioned about inextensible members, so 0, plus additional degree of freedom due to hinge. How many will be, how much will be this? This is a 2D frame, so it will be m minus 1 because it is in a joint. So m minus 1 will be how much? 2 members, 1 member, 1 member, 2 minus 1. So it will be 12 minus 6 plus 1. So it is becoming how much? 7. So this is how we calculate the kinematic indeterminacy. Now again, let us try to solve one for the beam. Suppose this is the beam given to us. Okay, so how many joints are there? 1, 2, 3. So dk will be 3, total degree of freedom, each joint has 3, 3 into 3, minus number of external reactions, 1, 2, 3, 4, 5, 6. Then number of inextensible members, nothing is mentioned, plus additional degree of freedom due to hinge. If the hinge is located in this manner, then we have to give 4. So ultimately the answer is how much? 9 minus 6, 3, 3 plus 4, 7. So this is the answer. Okay, so next class we'll be finishing it up, finishing the indeterminacy, and then that will be enough for you for your SSCJ 2019 examination. So we'll be just concentrating on some problems, and the basic, most of the all the things that are required, everything is discussed with you till now properly. So like if you have any doubt, you can comment on the video, and then we'll be discussing those doubts also, and we'll be ending this indeterminacy part altogether in the next class. Thank you.